Hi, this is Mrs. Ward. We are going to go over linear inequalities in one variable. Just to remind you of some of the terms, linear means that it's a linear equation, which means it has a degree of 1. And if I were to graph a linear equation, I would graph a straight line. So that's what the linear means. Inequality means that I am going to have either greater than, less than, greater than or equal to, less than or equal to. And then all of these that we're going to start today are going to be in the one variable. A6 means that this is back in the appendix. It's the sixth section of the appendix, if you want to follow along in your book. All right, just to review, you've done these before. If I have x is greater than 5, if I asked you to graph it, you would graph a number line. And what I'm requiring is that you have the number 5, you have at least one number less than 5 or to the left of 5, and one number to the right of 5. And x is greater than, since it's just greater than, I have an open circle at 5, and I'm going to shade all the points to the right. To write this in interval notation, that's where I use either my parentheses or brackets. My lowest number that I have is 5, so 5 will be my lowest number. The highest number I have is positive infinity. Since it does not include the 5, I'm going to write a parenthesis to show that that 5 is not actually included. And then anytime I have infinity, I'm just going to write a parenthesis as well. Then your book asks you to determine whether these are bounded or unbounded. In order to be bounded, that means you have a definite starting or stopping point, or you have both a definite starting and stopping point. Since like 5.0001 would be included, but not 5 itself, this one does not have a definite starting point, and then the infinity means that there's definitely not a definite starting point. So this is what's going to be called an unbounded inequality. Looking at the next one, I have x is less than or equal to -3. To graph it, I'm going to put the -3, one number to the left, one number to the right. Since it's less than or equal to, I'm going to have a closed circle on 3, and I want all the points to the left. So now to write it in interval notation, since it's continuing to the left without end, I'm going to say that that's going to be negative infinity. I got ahead of myself. Whoopsie, that's not infinity. Negative infinity, and then my upper bound will be -3. Infinity cannot include that, so that'll be parenthesis. But since my my system actually includes a point -3, I'm going to put brackets to show that -3 is included. Then if I'm asked to determine whether it's bounded or unbounded, because I include that -3, this is going to be a bounded inequality. That'll become important when we start graphing these. Now I have, what this is called, the next one I have x, and I'm comparing it to two values. So when I go to do 4, I'm going to have the number to the left. Whoopsie, this was +3. And the number to the right. And then when I have 9, I'm going to have the number to the left, the number to the right, and then I'm going to go ahead 6, 7, 8, 9, 10. So I have all my numbers. X is greater than or equal to 4, so I'm going to have a closed circle on 4. X is greater than, so that would include all the points to the right. X is less than 9, I'm going to have an open circle on 9, and all the points to the left. To write this in interval notation, my lowest point is 4, my highest point is 9. I include the 4, I do not include the 9. This is an unbounded inequality. Moving on to the next one. So if I ask you to review and I ask you to write these and I shade these, then if I were asked you to write the inequality, you're going to say x is greater than 7. And then in interval notation, I would have 7, positive infinity, parentheses on both, unbounded. See? The next one would be x is less than or equal to +12. So I'm going to go negative infinity to 12. I include that 12. This is going to be bounded. And the last one, since I'm shading on the outside, that means I'm going to have two inequalities. This one over here will be negative infinity to -5. I'm including the 5. The one on the right will start at 10 and go to positive infinity. To represent that my inequality represents both parts of this, I'm going to write the union symbol. And because I'm including this -5, it would be a bounded inequality. Moving on to the next one. It gives me an interval notation, and it asks me to just determine whether it's bounded or unbounded. Since I have the 7, I'm going to be bounded. Since I have both of them, it's going to be bounded, bounded, and then the last one, there is a typo there. These should be parentheses because I can never have a graph with infinity, and so this is going to be unbounded. And then make sure when you're doing these that you're able to graph them and write them as inequalities. In other words, this inequality would be -2, x is greater than or equal, x is greater than -2, and less than or equal to 7. And make sure you know how to graph all of them as well. Now let's talk about properties of inequalities. You have the transitive property. All the transitive property says is that if A is less than B and B is less than C, then A has to be less than C. Addition inequality says that if they are in the same order, in other words, A and C are the smaller numbers, B and D are the larger numbers. If I add the two smaller numbers, then it has to be less than the sum of the two larger numbers. If I add the same number to both sides, and I add a constant to both sides, that's not going to change the order of my inequality. If I multiply by a constant, that's where we start to get a little tricky. If my constant is greater than 0, so in other words, C is a positive number greater than 0, then the inequality symbol does not change. If my constant is less than 0, and I'm multiplying by a negative number, then if A is less than B, then when I multiply both of them by a negative number, my inequality symbol will switch. Those are all in your book too if you need to go over this some more. Solving linear inequalities. The first couple are fairly simple, so let's get this guy out of the way. So when you're solving an inequality, you're going to work it like it had an equal sign. So I'm going to isolate. I'm going to put all my things with x on one side, everything without an x on another side. So I'm going to add 7 to both sides. When I do that, I'll have 6x greater than 4x plus 19. Then I'm going to put the x's on the left side, so I'm going to subtract 4x. And I get 2x is greater than 19. Divide both sides by 2. X is greater than 19 halves. For decimal people, that would be 9.5. Either one would be acceptable answers. So that's the part where I solved it. Now it wants me to graph it. So I would graph a number line. Let's get this guy out of the way. Oopsie. Not what I want to do. So to graph it, I'm going to have my integers. So the number less than 9.5 is 10, the number greater is 10, and then 9.5 would fall there in the middle. It's going to be an open circle, and I'm going to graph all the points to the right. So that's the graphing part. And then the last thing it wants an interval notation. So to write this in interval notation, my lowest number is 9.5. I have a parenthesis because it's just greater than to positive infinity. It doesn't ask me, but if it asks me bounded or unbounded, I would say unbounded. Okay, the next one has a fraction that should not bother me at all. I'm going to solve. Let's keep the colors the same. So I'm going to subtract 3 from both sides, I think. We have negative 2x, 2/3 x is greater than or equal to x minus 7. Now I'm going to subtract x from both sides. When I subtract x, I'm going to have the negative 5/3 x is greater than or equal to negative 7. Now I'm going to multiply by the reciprocal, so I'm multiplying by negative 3/5. Now when I multiply by a negative number, you should remember that your inequality sign switches, so this will just be x. Now this becomes less than or equal to, and then this will be a positive 21/5. As a decimal, I believe that's 4.2. So when I go to graph it, I'm going to do the integer less than 4.2, which is 4, the integer greater, which is 5. 4.2 would be a little bit close to the 4. I'm going to have a closed circle, so that's 4.2. All the points to the left. And then finally, integral notation would be negative infinity to 4.2 bracket. Or you could have negative infinity to 21/5 bracket. Either one is acceptable. The last one here that I have on this page is what's called a compound inequality. Compound because you have two parts. In Algebra 1, you should have been taught to separate it as just two separate inequalities, where I take everything up into one inequality and I write it. Then when I look at it, I forget the other inequality and do the second inequality. So I'm going to have 2x plus 1 is less than 7. So I have two inequalities. I solve this separately, and at the end, I put them together. So when I go to solve this, I'm going to subtract 1 from both sides. Here I'm going to subtract 1 from both sides. Both of them going to divide by 2. So here I have x is less than 3. Over here I have negative 3 is less than or equal to x. So if I were to graph that, graphing is right there. If I were to graph that, negative 3 is to the left of positive 3. So I'm going to have negative 4, 2, negative 1, 0, 1, 2. Squeeze that in there, 4. I'm going to have a closed circle, negative 3, an open circle, 3. This is x is greater than or equal to negative 3. This is x is less than or equal to 3. So my interval notation will be negative 3 to 3. And that would be blue. But I didn't think of blue. Okay, so that was solving a double inequality or compound inequality. Next one is absolute value. You should remember absolute value means the distance from 0. So in this case, x minus 2, that absolute value is less than 4. So the distance from 0 is going to be 4 units. So if this were just a simple absolute value of x is less than 4, when I think about that, that means here's 0, 1, 2, 3, 4, 1, 2, 3, 4, 4, negative 4. X is less than 4, so that's all these, but it's also greater. This part would be x is greater than a negative 4. It includes both of those when I do an absolute value. So when I do this one, this x minus 2, I'm going to first write out an inequality where I have x minus 2 is less than 4. I leave it exactly the same the way I see it. The only thing is I took out the absolute value. I'm going to write a second one. When I write the second one, I'm going to still write that x minus 2. I'm not changing anything that's inside the absolute value. I'm going to compare it to negative 4, but remember up here it's going to be greater than negative 4. I solve both of these simultaneously. Add 2, x is less than 6. Add 2, x is greater than negative 2. And if I were to graph it, negative 2, let's see, make it longer. I'm going to have an open circle at negative 2, an open circle at 6, x is less than 6, x is greater than negative 2, which will be that area here, which should make sense because what happened when you talked with Mrs. Pesic about transformations, you know, that huge project you did where you did the pictures and you talked about transformation. This x minus 2 means that I'm going to take my absolute value and I'm going to shift 2 units to the right. So what I've done is I've taken this graph that I had up here and I'm pointing to it. You can't see that because we're not in the room together. I took this graph here, where it went from negative 4 to 4, and I just moved it 2 units to the left, and that's exactly what happened. So the negative 4 became a positive negative 2, and then the positive 4 became a 6. So that's what you're doing when you're solving absolute values. And so the next one I'm going to set it up, and then you can solve it on your own. So next one you should have x plus 1 is greater than or equal to 8. That's copying it down exactly the way I see it, not changing anything except for removing the absolute value symbols. And then the second half of that, I'm going to write the x plus 1, not changing anything inside the absolute value. change the direction of the inequality and change the sign, second one. And I'll give you a second to solve that, and then we'll compare answers. So whoever's, if you want to pause the video, and then we can report back in a second. That would be great. Okay, this one, when I solved it, this one's similar but different. This one is saying that your distance from x plus 1, the distance from 0 is greater than 8, so it's the outside part. So you're going to, when you think about this, you're going to have two parts of the graph. You're going to have outside, so you're looking at the parts that go outside of that distance. So I get 7 and -9 is my boundary point. So here's my -9, here's my 7. Closed circles on both, area on the outside. So when I go to write the inequality, it's going to be two parts. I'm going to have this part to the left, which is represented here, and then I'm going to have this part to the right, which is represented by this inequality here. So I hope you get that, and now we can move on. So the next one is an application, which is word problem. We love word problems. So I'm going to give you a second to read it. You're owner of a donut shop, and you're charging $7.95 for each dozen of donuts. Your costs are $165 a day. That would be something like rent. And then it costs $1.45 to have the sugar, flour, and so on to make your donut. They want to know how many dozens of donuts should you aim to sell if you want to make a profit between $400 and $1,200. So the first thing I have to do is I have to come up with a variable that represents the number of dozens of donuts. So to me, it makes sense to use D. So D will equal the number of dozens of donuts. So if I'm the owner of the shop and I'm making $7.95, I have what's called my gross, which is the amount of money that I'm bringing in, which does not account for my costs or anything like that. So my gross is going to be $7.95 for each dozen donuts that I sell. To find the profit, and if I'm in business, my profit is going to be my gross minus my expenses. So my gross, we just said, was $7.95D. My expenses are going to be that $165. No matter how many dozen donuts I make, I still have to pay that $165 plus $1.45 for each dozen of donuts that I make. That's going to give me my profit. So what I'm going to do is I'm going to simplify this. I'm going to have $7.95D minus $165 minus $1.45D. So I'm going to have 6.5D minus 165. That is going to be my profit. I want to make at least $400. So I want that to be greater than or equal to 400. But for some reason, I don't want to make any more than 1,200. I think that we said that's your most that you can make. That's the most that they make. It varies between 400 and 1,200. So now I'm going to solve this. So I can separate it or just know to add 165 to both sides. So that'll be 565 here, and then 1,365 here. And then I'm going to divide by 6.5. And when I do that, I think I get, hold on, I thought it was 58, but I'm going to make sure. Okay, when I divide 565 by 6.5, I end up with 86.9231. That's what my calculator is showing me. And then when I divide 1365 by 6.5, I get 210. So this one's fairly easy, the right side. I know that I have to make less than 210. I'm going to sell less than 210 dozen. But this one here, I have this 86.9. In order to make at least $400, I have to sell 87 dozen. So this will have to be 87 dozen to 210 dozen. So the correct answer is, it says, what levels I have to sell between 87 and 210 dozen donuts to make that profit. Now here's what is tricky about inequalities and more problems. If Like, let's say I had this, and this was like 86.1 is less than or equal to D. In order to make that profit, I still would have to round this to 87 because that 86 will not give me the $400. It'll give me, I'll be a little bit shy. On the flip side, if I had D was less than or equal to 210.9, you're tempted to round it to 211 because that would be proper rounded. But then that 211 doesn't will put you over the 1,200. So you cannot do that. So here you're going to have to stop yourself at 210. So be sure you're careful and you go back and read the word problem to figure out what you need to do. Okay, here's your homework for today. So this will be due next class, next time I see you, which will be on next class. So there's your homework. And I hope you had a good time. Thanks. Bye.